This is Sierra Dahl with Municipal Energy Edge Forum, and our presenter today is Gregory Young with Clean Coalition, and he's going to be talking about solar microgrid methodology curriculum that they're using for college courses in engineering, energy, and environmental science. So go ahead, Gregory.
Thank you, Sierra. Again, my name is Gregory Young. I'm a program manager with the Clean Coalition and have been deeply involved with the Clean Coalition's work for the last 6 years. And am primarily responsible. My day-to-day is running what I will be talking about, the solar microgrid methodology, the Clean Coalition created that helps in establishing solar microgrid feasibility studies, facilitating these type of projects, and as well as leading them to the RFP stage where they get actually built. Along with that methodology, we created a curriculum for a city college, Santa Barbara City College in Santa Barbara, which led students through the curriculum, which consists of 5 steps. I'll be going through those with the presentation today. And we'll give a little brief overview of our organization as well. I'm going to go ahead and share my screen and we can get started. Sarah, can you confirm everything? Can you see? How do things look?
Yeah, it looks perfect. Perfect. Yes, you're fine.
Great. Okay, going to jump in presentation mode. Okay, fantastic. So some may understand and know of the Clean Coalition, but I'm going to give a quick overview. So the Clean Coalition's mission is to accelerate the transition to renewable energy in a modern grid. We are a nonprofit who focuses on technical policy and project development expertise. We have a end game in which we believe that 100% of the energy will be renewable, 25% of which will be local, with the remaining 75% being remote. And so what we mean by local, and this directly ties with what we call a solar microgrid, is the installation of renewable energy within the distribution grid. This allows for the insurance of resilience while less dependence on the transmission. And when we're speaking of transmission and distribution, again, what I'm referring to here is distribution are wooden power towers that you see running along common residential streets. And what I refer to as transmission, the transmission grid is large metal power towers that run typically long distances to get remote energy generation to where people live and work. We essentially ground our work in real life projects, and typically start with facilitating these solar microgrid projects from start to finish. So what I mean by that is facilitating with other nonprofits, school districts, municipalities, businesses, everyone you can think of who would benefit from these type of projects, facilitating them, help them understand what they consist of. And we typically then follow through with a solar microgrid feasibility study, which helps the site understand the technical elements of a solar microgrid, like how much solar they would want, where it would be located, how much energy storage they would want, where that would be located, what type of resilience they would receive for their critical loads, as well as the economics, which is very important for these projects, right? How much energy savings they'll be receiving over the project lifetime, how much the project will even cost as well. And then we even go to the next step further, which we also help running the RFPs for projects, for these solar microgrid projects, where we get the designer, builder, owner, operator, as we call them, the DBU, to come out and propose on the project, submit their best proposal, in which we work with the entity on selecting the proposal, and then contract negotiations through construction. So we start from the beginning, phases of it, of just thinking about it, helping them understand what it is to even building it. Ourselves, the conclusion, we do not build, own, and operate, but we make sure that it gets done. So the benefits of a solar microgrid, to be clear, we call it a trifecta of economic, environmental, and resilience benefits. Economic, as I mentioned before, typically includes electrical cost savings. You're essentially providing a fixed cost of electricity compared to rising or escalating utility rates, as well as providing a value of resilience that would be achieved, right, in the event of a grid outage. Being able to keep those critical loads operational, whether it's a grocery store refrigerator that would lose supplies from the refrigeration going out, or even a hospital in which has several critical life-sustaining loads. Environmental, that's kind of a given. Solar energy is renewable energy source. But when also adding energy storage, you can time shift that energy and become optimized for grid citizenship by shifting that solar energy from peak generation period to when the grid is constrained, typically between 4 to 9 p.m. in California. And then also resilience is the third element of that, in which you're able to island from the normal grid, which will, in the event of an outage, and as I had mentioned, keep critical loads operational. Let's move on. So, kind of the meat of what we're talking about, where I'll be talking about today, is the conclusion solar microgrid methodology. This consists, as we see it, as 5 steps, and I'm going to go briefly over these because as I get more into them in relation to the curriculum that we led, I'll be going into more detail. So hang with me here, but briefly, step 1 is load profiles. So understanding the what we call the baseline load profile, which consists of recent annual loads, so electricity usage. It includes any additional electrical loads that the site is expecting, which commonly today is like adding EV chargers, or even electrifying their loads, so switching from gas powered loads to all electric loads. And then, so we'd call that the adjustment load profile. And then there's the master, which is very simple. It's the go forward load profile. It's simply the baseline, so the starting historical load plus the adjustment. And therefore, we, in the importance of that, of getting to this master load profile, is so that we can account for any future electrical loads that we can, offset using solar, right? To optimize the sizing of the solar and storage for the best economic value, as well as for covering any future loads that are considered critical. We want to certainly size the system so that it's not inadequate for economic and resilience purposes in the future, and so we're planning proactively, right? And then the important, the last piece is the critical load profile, and so that's simply the loads over the course, used over the course of the year that are considered critical, that must remain operational in the event of an outage. Step 2 is resource scenarios. So that's sizing and siting. So making sure, the amount of solar and storage is being sized correctly, as well as siting the location is even feasible, right? We're placing in locations that are actually likely to be built. And then step 3 is site layout. So now we have an idea of siting, like where these are going to be located, where we need to create a layout. So just really kind of top-down map imagery of the site with where these different assets will be going. But it's not limited to just solar and storage. In these site layouts, we also want to show where the meter's located, like where the solar will interconnect and the storage will interconnect to the, behind the meter. And also the critical loads and the critical load, like where the panels are that have these critical loads, in case we need to replace the panel so that it operates in a smart way, which I'll get to later. Step 4 would be the economic analysis. So using all previous steps, we essentially run we run economic financing options, which allow for the conclusion of the 25-year typical lifetime results for a solar microgrid project. This consists of, knowing the CapEx, so capital expenditure of the project, the operational expenditure of the project, any type of incentives that will come with that through, the ITC incentive or others. SGIP is another one in California that then add to the net project cost. And then we also, run financing options such as a PPA, not only as, like I was mentioning before, a cash purchase. So a power purchase agreement, PPA, is a common way of financing these projects, and are typically seen, especially with sites that, one, don't want to deal with any of the running of the equipment, but also, kind of just to ensure that the equipment works properly. And then the last step, 5, reporting a recommendation. So this is taking all previous steps, the conclusions from them, putting them into a nice tightly packaged presentation, and then also providing recommendations and next steps. So how does this, how does all this information transcribe into a curriculum, right? One especially that can be taught to students in a course. So to give an example, we ran a solar microgrid curriculum course through Santa Barbara City College in the fall of 2023. So what I mean by we ran it, it was essentially taught by Professor Bill Dinklage in his Energy and Natural Resource course. It included 16 students and included clean coalition tools and support, as well as other industry standard tools. So what I mean by we ran is that we taught the professor, essentially, we helped them understand the methodology. We were there directly for support. That includes, even attending, some classes that he needed us to teach certain elements of the course that he didn't feel, confident enough in, and then also even holding some extra office hours so that students can come with questions that they may have had. So this 5-step methodology turned into a 6-week curriculum, and I'll make that clear in the next slide why. And it involved our clean coalition, solar microgrid methodology. The curriculum occurred, like I said, in the fall 2023 semester. Included 2 classes per week, an hour and 20 minutes per class. Had 1 class for a holiday, and this calculated just under around 15 hours in total class time. Occurred at Santa Barbara City College, I had mentioned, and the why at the end is, one of the key drivers, right? It really provided students with a unique combination of practical challenges and guidance in able to transform the classroom into, just this interactive launch pad for their careers. It really helped them use industry standard tools, as well as understanding industry standard key terms, and also understanding the methodology and creating a solar microgrid feasibility study for their campus itself. So they could actually, use this knowledge to teach themselves how to run these studies for their own school. So it not only did it give them, knowledge and theoretical, it gave them, equip them with theoretical knowledge, but also gave them these tangible skills and confidence. Okay, so how does this really transcribe the methodology to the curriculum? So, week 1, I had said was, or step 1 in the methodology, I said was load profiles. In the week 1 of the curriculum, that really kind of equaled understanding electricity interval data. So understanding what a load profile is, what it looks like, and the different types as the clean coalition defines it, as well as billing details, like what does a PDF bill look like from a utility. I'm sure they might have seen one before, but not understood what it even means, and really even how to translate it. So we help them understand what a PDF bill from a utility looks like in week 1. in week 2, we ran through a solar design software called Helioscope, which we typically use in our modeling and our creation of solar generation profiles. So this means essentially drawing out where the solar would be located, whether it's a flat roof, tilt angled solar, or if it's roof flush, it's an angled roof flush design, or even a solar parking canopy. And so that includes, a bunch of other, details I'll review in the next few slides. So week 3 is, the Clean Coalition's value of resilience methodology. So this is how we essentially size our critical loads, how we determine the value of those critical loads in the event of a grid outage, and the solar microgrid being able to provide resilience to them, and then also sizing the battery energy storage system. Week 4 was economic analysis, so using an industry standard tool called Energy Toolbase to take their load profiles, their solar generation profiles they created through Helioscope, and their battery energy storage system sizing to run through Energy Toolbase's economic modeling platform and get to essentially the economic results. Week 5 included project table creation and presentation preparations, so that they can understand what a feasibility study, solar microgrid feasibility study, looks like, and how to present their findings. And then week 6, this last week, and this is the real reason why our 5-step curriculum turned into a week 6-week curriculum, is because this last week 6 was for the students to have any type of final review of their presentations, and also to present them to key Santa Barbara City College staff and their professor. Okay, so to go into more detail, week 1, analyzing load profiles, electricity data. Topics covered included, some very basic but very important pieces. So distinguishing between power and energy, kilowatt and kilowatt hour, understanding what electricity usage data looks like. And so we refer to this as interval data. And what that, really means is, as energy is being recorded from your meter, how that data is represented, typically in an Excel file, at every 15 or hourly increment. So when we look at a load profile, we see it as typically a full calendar year. If it's 15-minute interval, it would be 35,040 intervals. And if it was hourly intervals, it would be 8760 intervals. So what that looks like, and then how to interpret it, right? So how to then understand some, as the energy is being used in the site, like how that appears on the data. And then also to understand that sometimes when downloading electricity data, it will come with errors. Missing interval data, duplicated interval data, and then how to clean that, which we taught the students through our Clean Coalition's solar microgrid analysis processor, which we refer to as the SMAP. It's a tool that encompasses many key processes in order to run the solar microgrid methodology in the way that where I've described. And so one of the first steps is cleaning that data. So we have a simple tool. You just plug in the data, and it will spit out a full calendar year's worth of data that will have 35,040 intervals. The next step is calculating, total annual load and peak demand from this baseline load profile, which is the result of cleaning the data. Is getting this baseline load profile to start with, and calculating the total annual load and the peak demand. Those are commonly practiced things to do, right? When running through the methodology, and just in general when sizing and establishing a solar microgrid. Also, we help them decipher electric utility bills and understanding meter rate schedules. So most sites have, especially in the commercial realm of things, they have different rate schedules, and they've vary depending on the utility you're in, and how to determine what a rate schedule, or what a rate schedule would be for a specific meter based on energy usage and demand. And then also developing a adjustment load profile. As I explained before, we include in our methodology an adjustment load profile because we want to anticipate for any additional electrical load. So this includes EV charging as well as electrification. And then combining at the very end the baseline load profile, the original profile we had cleaned, and then the adjustment load profile for any additional electrical loads into one, making the master load profile. And again, the tools that students used for this week included the SMAP, the Conclusion Solar Microgrid Analysis Processor, as well as a little EV charging profile creator that Conclusion used to simulate typical EV charging for for a site, which can vary. In this case, it was a workplace and public EV charging profile. Week 2, so this is mastering solar design and through helioscope. So we worked with helioscope, which is technically owned and operated by Aurora. That company name might be more familiar to folks. But helioscope is their commercial design platform, while Aurora is typically residential. We have a good relationship. We have a really good relationship with Aurora, and they we were able to work with them to get all students a student license to use helioscope on their own throughout the course. And we were also able to get an Aurora personnel to come in and teach how to use helioscope, the tool, in one of their classes. So the topics covered by the Aurora personnel included, solar panel and inverter choices, choosing the different types and brands of inverters and solar panels, kind of how the panels themselves, convert sunlight from DC to AC through the inverter, how the impact of tilt of the panel and azimuth, and how the spacing and shade, how the spacing of the panels and therefore potentially the shading of the panels through the panels tilt, as well as surrounding trees can impact a system's energy output. How there are different mounting system options, like I was saying earlier. There's fixed tilt racking, as well as flush mount or ground mount, or even carport structures. And then also to the net zero calculation, so which the industry is commonly referring to, and people are trying to achieve, right? That 100% net zero, which in short is that you're generating as much as you're consuming over the course of the year. So you'd be 100%. You're generating 100% of what you're consuming, not necessarily in the same time, because there will be certainly days that you're generating more than you're consuming, or vice versa. But over the course of the year, right, that you're generating, your total annual generation is equal to your total annual load. And then also which is vital to understand and do in helioscope, is how to draw a system layout, how to draw obstructions on roofs and trees that would affect the shading, as well as using LiDAR, so which stands for light detection and ranging data, and how to essentially use that to draw the trees at the correct height, or the roof at the correct height. So they were students were directly integrated into using this industry standard tool in the kind of the most commonly used ways. Week 3 is our value of resilience methodology, which I'll briefly state is the way the Clean Coalition really tiers loads and then ascribes value to those loads. So in a typical facility, there are a facility will tier their loads. Tier 1 being critical, mission critical, life sustaining loads. Tier 2 will be priority, and Tier 3 will be discretionary loads. And those typically pan out as follows, where Tier 1 is about a 10% of the total load, Tier 2 is about 15%, and tier 3 is the remaining percentage of the load. And overall, the resilience should pan out with enough solar and storage for a typical site that you achieve 100% resilience for tier 1 loads, about 80% resilience to tier 2 loads, and 25% resilience to tier 3 loads. The conclusion uses its solar microgrid analysis processor to determine the battery system size based on the critical load profile you include in it. So this step is critical for sizing the battery. And you see on this imagery to the right, this is kind of direct output from our SMAP. What it's doing here is it's saying, like, hey, here's the load profile you submitted into the tool. Here is the critical load profile you submitted in the tool. Here's the solar generation profile you created from helioscope that you submitted into the tool. Now, on the worst case solar generation day, what is the battery system size you need for indefinite resilience for your tier 1 loads? And so that purple spike at its highest point you see in this graph is the battery system size. And so then you would want to use that battery system size going forward to then run the economics, as I'll describe in the next step, in order to not only achieve resilience to your tier 1 loads indefinitely, but also for economic purposes. Now, week 4, this is the week that we used Energy Toolbase. So in this week, we not only help the professor understand how to use Energy Toolbase, which can be a complicated tool. There's a lot of moving parts in it. But we also held some office hours for students to give them a helping hand with the tool. But in particular, topics covered for this week includes capital and operational costs for installing solar and storage. It includes the variety of incentives available for solar microgrid components. What are discount rates and electricity escalation rates? What are the strategies you can select for the battery energy storage system for economic outcomes? So this includes demand charge management, energy arbitrage. This includes the different financing strategies such as cash purchase or power purchase agreement, PPA, and then also to electrical bill savings, right? The results of all of this and how it looks over a 25-year cash flow period. So when using ETB, students really implemented all of the previous steps or weeks, the learnings from previous weeks, to make sure that the energy Toolbase run that they created is yielding accurate results. So this includes importing the master load profile into the tool, and includes importing the solar generation profile they created in Helioscope into Energy Toolbase. It includes configuring the battery in Energy Toolbase from the sizing we determined in the previous step through the SMAP, the conclusion SMAP. And then it also includes ascribing different values for each, right? A cost per watt for the solar, or cost per kilowatt hour for the storage. It also includes understanding, how much to input for operations maintenance. For a cash purchase scenario, it's determining, when, essentially how much operations would be. So cleaning electrical panels from common debris or soiling. It includes the replacement of inverters or energy storage systems after they've been degraded over their typical life frame, which is about 15 years. And just making sure the system is maintained properly, which all comes with a cost. And then also includes understanding rates and comparing the available solar and storage friendly rates and how they impact the economics. So you can perform in Energy Toolbase, you can perform rate switches to available solar and storage friendly rates, and see the results from that, see how much additional savings you achieve simply from knowing which rates to use. And then also, as I mentioned, financial scenarios. So comparing a cash purchase scenario to a PPA scenario, all under the different 25-year outcomes. And then lastly, week 5 is really just review and presentation creation. So students were given some time here to gather everything they've learned and then put it into a presentation. So we help them understand from past solar microgrid feasibility studies that we've done what a presentation like that would typically look like, and how to really present compelling key economic results, how to provide a concise overview of all the analysis steps that they took, and then going into certain steps in depth to clarify their results, and then also how to synthesize all this and recommend what the next step should be. Then week 6 was the fun week. Students presented. We had a distinguished audience of Santa Barbara City College staff members, as you see here listed in bullet point, as well as Santa Barbara Foundation members, as well as Clean Coalition personnel. And in short, we had fantastic feedback. We had wonderful quotes from the superintendent of Santa Barbara City College, as well as the professor and the student. But of course, the excitement and everyone's feedback was much more robust than I could fit on one slide. So, but this just give you a taste of the wonderful reactions we got. And that concludes. So hopefully I did so in good time. And Sierra, we can proceed as you'd like.
All right. Impressively thorough program. Excellent. So anybody have any questions here? If you want to take down your slides, that would be great.
Sure.
Bob, go ahead.
Great presentation. This is really important.
We can't hear you very well, but it's not just your voice, it's the audio. You're talking, but nothing's coming out. So I hear a little bit now and then, but not much. No, can't hear you at all right now. Why don't you call in on the phone, Bob? Jeff, go ahead.
Yeah, can you hear me okay?
Mm-hmm.
Yes,
Yeah, great presentation, great course. And maybe I missed it at the beginning. What was the total number of classroom hours? And how much homework time do you think the students had to spend?
Yeah, good question. So there's 15 hours of total class time. Homework hours, that part of the curriculum I was not too, I wasn't abreast to. The professor, was the one that described any, told any of the kids that what the homework would be and whatnot. But yeah, unfortunately, I don't know that answer. But I could easily, if you'd like, check.
No, just I mean, to me, I obviously I work for a solar developer, and I could see a course like this being internal or through some local community college where we're located for almost any new employee. Maybe not accounting or HR people necessarily, but anyone who's going to be involved in sales or in project pricing or any of these, because it seems to be a very comprehensive. Start at the beginning. you said it, understanding the difference between power and energy. 98% of our new employees coming in, including, some very technical people, have no clue on the difference. And it takes a really long time to try to really get them to understand these kind of nuances before they can really, and that kind of base understanding is really important to make it click ultimately. Right. I mean, and so I think that's great stuff. So I'm very impressed.
Jeff, this is Craig Lewis. Just to kind of follow on to what you just said and to your question, the Clean Coalition, we put all of our new personnel through the solar microgrid methodology training, and as you indicated, it just gets their brain, it kind of puts that fundamental foundation about energy and power into their brain, which everybody needs to know that's going to be on the Clean Coalition team. So it is really fundamental stuff. I think in answer to your question in terms of how much outside time, my guess is it's probably like a 2 to 5x, right? Classroom time to homework time, just depending on how seriously people take it.
Yeah, makes sense.
If they're really gonna understand the tools, it's going to be kind of on the 5x side. So 15 hours of class time, they're going to be doing 75 hours outside.
Yeah.
And if they're just kind of skating by and relying on, they broke into teams. So if somebody just kind of skated along and was part of a team and let other people do the heavy lifting, they could probably get by with maybe a 2x, right? So they get 30 hours in just to kind of understand the basics and then rely on other people for getting down into the gory details. So I would say somewhere between 2 and 5x for outside time beyond the classroom time.
Yep. No, it's good stuff.
Right, I see Bob put a question in the chat, but we'll go to Rick right now and then come back to Bob. Go ahead, Rick.
Yeah. My question is, are you going to do outreach? I thought the comment about community colleges was quite apt. In Massachusetts, particularly, the community colleges have devoted themselves to energy training, but it's usually just weatherization. This would be a fantastic thing to add to that whole set of institutions that are trying to do what Obama tried to get going, Clinton tried to get going, then Obama, Carter before him, and these waves of trying to train people to do the clean jobs. And Massachusetts is a state, for example, that's very receptive to that. Plus, you have higher level education, environmental engineering, which I think could eat this stuff up. And I don't know how you want to interact with them, but I think it would be of great interest, and I'd love to share it with my colleagues at Boston University.
Yeah, I mean, we welcome all introductions, and we think that this could be, a great way to integrate students to actually use the tools that are being used in the industry, which I think oftentimes is what separates, people from actually, understanding where their place could be, right, once they graduate. And it can just be so theoretical in concept that it just doesn't paint the picture well enough to understand for them like where to go. So yeah, we're more than welcome to have any introductions that you would like to provide. And yeah,
Thanks, Greg.
Yeah, thank you, Rick. Appreciate it.
Great stuff.
I'm going to take the question that Bob has in the chat. My question is that if there's any space given to emergent technologies such as biodirectional charging and how that impacts the planning and modeling process. Does that topic just come up during curriculum, or are you waiting for the products to actually come to market before adding it to the curriculum? Good question.
Yeah, thank you. And thank you, Bob. So I'm just going to read off Craig's response really quickly, and then I'll add my own comments to it. So Craig said that the Clean Coalition can model any energy flows that are associated with any smart energy solutions. Typically, the solutions are focused on those that are commercially available. So just to comment off of that, I imagine that in the class, while we weren't attending every single class in which the professor led of the curriculum, I imagine that topics like that came up. Like he didn't just teach the curriculum to the extent of our methodology. He probably talked about other renewable energy, and smart energy solutions that are out there. But in terms of our methodology, we use, as Craig said, what is commercially available to run the economics or the sizing. And so in the case of bidirectional charging, just to talk to that specifically, right, while Clean Coalition internally could use its own model to design for that, say energy tool base, for example, which is commonly used for most commonly used for economic modeling, they don't have because it's not a product out in the market, right? They don't have a bidirectional modeling, part of their tool yet. And so we in short, we really only teach to what is available, right?
Hey, Manir?
Yeah, this is Greg, this is amazing. And Craig, as always, huge fan of all the work that you're doing. And I just sort of building up, well, I had a couple of quick questions. So this curriculum, is this part of is there an engineering, are there any requirements to, taking it as a student, and how is the credit structure contribute to a degree or a certificate in any way?
Yeah, of course. Really good questions. So I think that this curriculum could be taught, in a variety of different, whether it's, a student just starting off in its college career, or one who's, down its career path in engineering or, environmental studies. So it can be placed wherever on the spectrum of the college student can be at, just depending on how it is taught, right? In the case of this course, it was for energy and natural resources course, which is a course that a student could take without having any prerequisites. So that kind of answers your question there, that this curriculum as it has currently been taught has been for a student without any prior knowledge on the subject. Now you could absolutely turn this into a much more intensive course that forces students to understand more than just the basics, right? That goes into much more of the details when it comes to the engineering and the single line diagram, designing elements of it that would then put it kind of into the category where the developers would go to when they want to actually, they want to get to before they can construct it, right? And so there's different elements of the complexity you can get into. And so I could see it going, the full spectrum.
And Manir, just to add on to that, in terms of whether they get a degree or certificate, in the case of putting this into the curriculum of a college course, it's obviously going to count towards whatever, it's going to count as college credit. So as that applies to whatever degree or certificate somebody is pursuing, the answer is yes, right? If this was run by the Clean Coalition, we'd have to go get a certification, somebody would have to stamp something and give us we're not, Clean Coalition is not in that business. We're not going to do that. So, but if it's put into a college course, then obviously the credit associated with that college course would apply to somebody's matriculation process.
Mm-hmm. And I'm just building upon like Rick's suggestion, of introducing it into, like, we're getting you guys introduced into the bloodstream of Massachusetts, and your process into the bloodstream of the Massachusetts ecosystem, I guess. And I'm trying to think, like, for example, this is a vocational school, but this would belong at the Franklin Cummings Technical Institution as just one example where they're really going all out on trying to develop the clean energy technical skill development. Like, for example, can we share a link to this particular webinar and discussion with them to sort of give them a sense, or do you have a little package that we could forward to the group there? On
Yeah.
the course?
Yeah, thank you. Yeah, we do have a 2-pager, which we could send your way on the curriculum. And we're also currently working on a kind of a curriculum, process, like a curriculum packet, really, which would essentially, with little help from the Clean Coalition, provide the professor with the essential steps and the key terms and everything they would need to create a curriculum out of, in their own fashion, because every professor will want to do it probably in a different way. And so we're currently working on that and can have that available, for those who show further interest after the 2-pager.
Yeah, that would be just awesome to get that. I see some folks asking for it too, so.
Yeah, absolutely.
Do you want to put that link in the chat? Richard Pate just asked for that.
Yeah.
Sure.
And you can send it to me as well, please. No.
Haley,
Yeah.
Haley's on the call. Haley, can you do that while Gregory's keeping his attention on answering questions?
Sure, it'll just be 1 minute and then I'll send that in the chat.
Okay.
Yeah, and also send it to me, Haley, please. And I'll put it up online. Any other questions? Okay.
I have a question for the group, which is, do you see this as being something that you can take to your, academic institutions that you work with, and or use it internally, like Jeff was talking about, in terms of use it for internal training? The Clean Coalition, our mission in life is to accelerate the transition to renewable energy in a modern grid, and we focus at the local level. So solar microgrids are fundamental to the Clean Coalition's mission. We think they're the killer app, so to speak, using old school tech terminology. So we want to enable people to proliferate solar microgrids, and we want to get this training curriculum out to you all, and we want to have it in a way that's very accessible, and you can run with it, right, and not have to rely on the Clean Coalition to get this knowledge out there. So my question is, do you see this as being something that you can take to your academic partners, clients, collaborators, and or to internal operations?
It's got one from Richard Pate that says absolutely.
Yeah, this is Jeff. I mean, certainly I can envision how we could do this internally. I mean, the instructor side of stuff would be a little bit complicated in the current iteration, the way we have things structured, but I think that could be. But I'm more interested, we're headquartered in Connecticut. Connecticut has got, with all of the prevailing wage and apprenticeship requirements and stuff like that are now out there, their apprenticeship programs for solar and solar installers is very minimal. So we're talking with some potential partners in community colleges to actually start up a solar apprenticeship program or solar installer apprenticeship programs. This kind of thing would slot right into something like that. I could envision very clearly. One question I had, would Aurora and Energy Toolbase, you think, be amenable to educational licenses more broadly than what you've done just, in your local, first runs through this class?
Yeah, good question. So Aurora, Helioscope, absolutely. They are very open and supportive of using their tool in teaching this type of information. So you can get licenses through them pretty easily for each student in your course. And then in terms of Energy Toolbase, they're a little bit more of a tight-knit company, and I can't speak for them and how they'd respond to your offering per se. But I think a little bit more of some deal, massaging may need to be had.
Hey, Gregory, just in terms of the way the licensing works for Energy Toolbase, I think you can get 30-day free trials.
Yeah, you can.
Okay.
Yeah.
So you got, you're not going to start teaching the Energy Toolbase stuff until you get into like halfway into the curriculum. So you're only going to need
Yeah, that's true. Yeah.
Like if you have 1 month of free trial, you're going to be covered. And the other thing is that the professor can take a license. It's not that expensive for a single seat, and then just kind of share the password. Don't tell the Energy Toolbase folks I said that, but the main thing that the energy toolbase folks don't want is they don't want a bunch of people asking tons of questions, right? They don't want to get bogged down with a bunch of newbies on their platform that aren't paying anything to use it, right? I think
Yeah, that makes sense.
you don't get, you don't on the free trial, you don't get access to customer support typically, I don't think. So that kind of protects them. So Energy Toolbase loves people using their platform, loves students getting trained on it. They just don't want the burden of dealing with the customer
Yep,
support
makes sense.
aspects.
Dear, you have another question? Or Jeff, are you done yet?
I'm done.
Manir?
No, thanks. I guess, this may open a small can of worms, but it's just on the economic analysis, given that that's going to be changing pretty radically, that we, at least well, I shouldn't say that. I shouldn't wish, I don't wish it, but the economic analysis can be in flux. And how do you guys see dealing with that in the
Yeah. So yeah, I mean, good question. I mean, immediately, I would say that Energy Toolbase is extremely good at incorporating any changes that happen in the industry. So one exact example of that is that from California's switch from NEM2 to NEM3, they made all the necessary changes across all all utilities in California and across all rates, and they made that extremely inclusive in the tool and easy to access and understand. So that shows an example of how they can maintain and keep up with the, I guess, potential rapid changing of the industry. Yeah.
Yeah, and just to add on to that, Energy Toolbase and Helioscope are both amazing platforms. That's why the Clean Coalition has standardized on them. And Energy Toolbase, to Gregory's point, not only did they provide the NEM3 or net billing tariff, whatever you want to call it, those two terms are synonymous. Not only did they incorporate that immediately, they also made sure that the NEM2 was still available as a selection point, because there's a 3-year grandfathering period for those who hit the minimum eligibility requirement, which was getting their interconnection application in. And then they had 3 years from the date that interconnection application was in to when they actually build the project. So there's a 3-year period that you have to still have access to NEM2 to make sure that you can do the analysis on those grandfathered projects.
Yeah, definitely true. And in combination with that, their utility rate database is expansive. It's the largest that I know of that exists, and their team is extremely helpful and quick to respond. So if you need any updates to race schedules, then they can make it happen, which is hard to come by, honestly, from other tools that I've used, because it's a complicated thing to be able to understand those changes that have been made, and then how they're reflected in terms of mapping over the load profile you add in the tool. So yeah, their utility rate team is incredible.
Okay. Anybody else? All right. Well, tomorrow we have Cleaner Rob talking about some of the issues related to meeting clean energy goals when faced with data-centered load growth, and particularly centered around AI. So any ideas on that would be helpful if you can attend. David, go ahead. David Dupro.
Yeah. Oh, hi. Thanks. Yeah. So thank you. This was great. Craig and Greg, I'm really fascinated by this. And as usual, it's so well thought out and so clearly explained and so relevant. But Craig and maybe Gregory, if you could talk a little bit more about the comment, or just elaborate for a minute on the comment you made, Greg, about how you want others, including the folks on this call, to sort of be talking to people about this curriculum. What level do you expect people to, or are you interested in inviting people to get into with in terms of presenting the curriculum as an opportunity for schools or companies or other organizations or nonprofits, et cetera?
Yeah. So, I mean, we've shared this 2-pager, and I would say using that as collateral in your talks to businesses, to schools, into integrating this curriculum into a course of theirs would be the first step, and then combining it with the fact that this curriculum can provide the students the necessary hands-on knowledge to start building their career in this clean energy transition that we're trying to accelerate, really. And this includes industry standard tools that they get to use to make that happen, and to make something to help make something standard. And what I'm talking to is a solar microgrid to help that to help that become standard in all for all sites, and that goes from sites that are already built, but especially sites that are going to be built, because currently, as we're seeing, the architects don't know how to incorporate this kind of stuff. And unfortunately, while there is mandates to put some solar on their roofs, solar microgrids are not even in their scope of knowledge. So getting it in front of the growing young population in school can achieve that.
Yeah, and I'll just add, David, there's multiple layers of how to push this, and it really depends on what your position is. I think there's people in this call and certainly within the Sierra Doll, forum. I call it Sierra Doll Forum because I always forget what the other name is. There's some of you are working directly with academic institutions, and in some cases, I think working for academic institutions and teaching these types of, energy, environmental studies type classes that this curriculum fits nicely into. So people like that are teaching these kind of classes already, right? Getting them to just understand how it's going to be, how they can embrace it and do it without, having to give up, too much time of their life, right? It's always tough to incorporate new curriculum, but we're trying to make it as easy as possible for the academics to do that. So to the extent that people have relationship, you are an academic or you work with academics. I know I'll call out Munir. I know Munir works closely with some academic institutions, right? So he's got an easy path. He's going to have to explain this deeper than if you're just coming across somebody who's got a site that is you hear that some building is going to get constructed, and you're like, hey, have you considered a solar microgrid method? The solar microgrid. Yeah, here's this 2-pager on the solar microgrid methodology, so you can start considering that solar microgrid to the point that Gregory made. Right, we need to get a serious kick in the pants to the world of architecture and designers. There's people like Robert Perry. I'll call out another person on the call here. Robert's an amazing networker, right? He's talking to all sorts of people all of the time. And so he's going to come across lots of instances where it's just like, hey, have you considered doing a solar microgrid? Here's a solar microgrid methodology that's well tested, right? It's time tested, and you should think about it for whatever project you've got, whether it's a retrofit or a new construction or whatever. So there's different levels of engagement. David, we've collaborated on lots of things over the years. So I think that when you're dealing with policymakers, I associate you with the policy world. It's like when you're dealing with people at the California Public Utilities Commission, it's like, hey, we should start forcing people to go beyond just solar, but think about the resilience element too, which means it has to be a solar microgrid, right? And here's some ways for policymakers and staff up at the CPUC to start considering it, right? It's just a starting point. Give them the 2-pager, give them a link to this webinar recording, right? Those are kind of the starting points.
David,
Okay.
you have another question, or you still have your hand up?
No, that's great. And by the way, Craig, the name of this organization is the Sierra Club. Don't forget.
So I think Munir coined
I've
that
been a
one.
member of the Sierra Club since I was like a teenager, so I guess.
But this is Sierra's club.
So there you go. Apostrophe S. Thank you.
Nice.
So David, is that a hand up or is that you just didn't take it down
No, I
yet?
haven't taken it down yet. Yeah.
Okay, so we're back to, again, tomorrow's presentation, and anybody have any more questions before we go? Because we're out of time, but always have room for a couple more. Okay, great. Well, hope to see you all tomorrow. It should be a really interesting discussion and a relevant one, and outstanding work. Gregory and Craig, of course, your organization does some amazing things and is so important what you're doing. So, as well as the rest of you, this is such a great group. Okay, we'll
And
see you tomorrow.
Sierra, just to be clear, Clink Ocean, we love this organization, and we're going to be sending various people, team members. Like today, we've got Gregory and Haley and myself. Sometimes we're going to have other people depending on what the topic is. So
Yeah,
be
perfect.
kind to them when they join. I know you always like to know who's on, and you'll get the rogue Clink Ocean person whose name you don't recognize from time to time. But just welcome them in. They're part of the
Well,
team.
I haven't kicked anybody out yet, so I think we're in good
Okay.
shape. And Gregory and I discovered we both live in Colorado Springs, much to both of our surprises. So, how
Whoa.
about that?
We'll have to see that.
Yeah.
I didn't know that's where you live, Sierra. I knew Gregory lived there. Next thing we'll find out is Gregory's a Star Wars fan, which I don't know that he is or isn't, but I know that you have a long history with Star Wars, Sierra. That's
Oh gosh, that's taking over my life right now, actually. It's another story. Okay.
Yeah.
All right. Thanks, guys.
Yeah,
Talk
may
to
the
you
force
later.
be with you.
Later.
See you.
Bye-bye.
Force be with
Yes.
you.
You see,
All right. Bye-bye now.